Hello there, friends and neighbors. I'm going to show you a complete results section with regression or correlation context. So these are the sections, the typical components that are required from any results section. Certainly in your introductory stats class this is the case. So I need descriptive stats, a graph, and your inferential stats. Your inferential stats consists of your HO, H1, and alpha, the assumption check, confidence interval, test statistic, degrees of freedom, and p-value. Make a decision about HO, and if there's a confidence interval, interpret that. And finally, interpret in plain English for the research context. So I've got a data set already loaded that is looking at two standardized tests for math scores, the CASAS and the GED, and we want to see if they correlate. So we'll go first get our descriptive statistics. Statistical analysis, they're continuous variables because they're quantitative. You're going to choose numerical summaries and choose both of the variables and then click OK. This gives me my means and standard deviations and sample sizes. Copy, which is most of what I need for my descriptive statistics in this case. Paste. And then I'm going to select the table, and I'm going to choose a monospace font like Courier New, and there we go. So there's your descriptive statistics. One thing that's missing is the Pearson's R, the correlation coefficient, which can be thought of as a descriptive statistic. So I will do that now. Statistical analysis, continuous variables, test for Pearson's correlation. And choose both of the variables and click OK. Now it gives me a graph, which is extremely useful, among other things, and it gives me my correlation, my Pearson's R, which is 0.601. I'm going to copy that and paste it here into my paper. There we go. Now, the graph, if you've got Windows or Mac, you can just right-click on this and copy it and paste it. I do not. I'm using Linux. I'm using Ubuntu. And so I'm going to do this a little bit differently from what you would do. I'm going to paste it, Tools, select, cut it out, and paste that into my paper. Cut. Paste. Anchor as character. Make it smaller. Cut it and paste it. There we go. I'm going to use this to screen my data to do my assumption checks. So, oh, actually, you know what else would be a nice thing to have for the descriptive statistics? The regression constants can be thought of as descriptive stats too. So I could have B naught, the intercept, and B1, the slope. I can put both of those in here too. Let's get those. So I'm going to put that away. Go statistical analysis, continuous variables, linear regression. And I'll choose, it doesn't matter which one is the outcome, which actually is a sign that I probably shouldn't be using regression. But I think GED is actually the response, and CASAS is probably the input. And click OK. And so this is what you would get from a regression analysis. I would get the intercept is 43.4 in the sample. Okay, and the slope, using CASAS to predict GRE, would be that. Now, that'll change if we swap it, so we're using GE to predict CASAS, but I'm not sure that makes as much sense. Anyway, so the null hypothesis, HO, is that there's no correlation between these two. Rho equals 0. Against the alternative, that rho does not equal 0. Alpha, you get to pick, and unless you've got a great reason, you just choose 0.05. Now the assumption check is pretty complicated with regression and correlation. It's pretty complicated. We're assuming a lot of things, and if for purposes of this class, we're going to keep this simple. Okay, it's okay that you're not going to necessarily master this. So what I'm looking for is, here are the basics, that we've got linearity, normality, of both x and y for correlation, or just y regression. Now, I'm going to treat this as a correlation, so we're going to have them both be normally distributed. Normality, linearity, we have to have independence, of course, and we achieve that by simple random sample. Let's see, and then we have to have no outliers or influential observations. And then we have homogeneity of variance. Let's say it this way. The spread is about the same for all levels of x. So if I, let's go look at our graph, which is right here. All right, now looking first for normality, I'm going to look in the box plots to see if they look skewed, and they don't. They look okay. Next, I'm going to look to see if there's some sort of a curvy line or some other nonlinear shape, and I don't see anything like that. So, looking at that graph, it looks like linearity is okay. Normality is also okay. Influential outliers and observations, let's look for that. I don't really see any. This guy might be, that guy looks like it might be an outlier. No, not really. It's not an outlier horizontally or vertically. It might be influential. This would influence the intercept most likely, but it doesn't look too bad. So I don't really see influential observations or outliers in this case. Usually there are. Usually our results are pretty bad. And then finally the spread. I don't see where it's particularly like wide on one side and then narrowing down like a funnel, or wide on the ends and thin in the middle like a bow tie. And I don't see narrow on the ends and wide in the middle like a football. I don't see anything like that. It basically looks like it's reasonably homogeneous variance. It looks okay. All right, moving right along. Let's go get our actual computations. Now I ran them already, so they're here. I'm going to look at the correlation output. Here's the t, test statistic, degrees of freedom, and p-value. To test the hypothesis that the population correlation rho is in fact 0. Here's your 95% confidence interval. Copy, paste. And so, decision. Well, the p-value is less than alpha, so we reject HO. That means there is sufficient sample evidence to support the claim that there is a correlation. You rejected the null hypothesis. Null hypothesis says that rho equals 0. I don't believe that. I rejected it because the p-value is low. Furthermore, the confidence interval says we are 95% confident that the true population correlation is between 0.31 and 0.79. And that's it. That's a complete results section from beginning to end for a correlation analysis. A little bit of regression thrown in. All right.